Today we start off our discussion on introduction to SAS arrays. Now SAS arrays can be a very useful tool when we want to transform a lot of variables. Okay, it's a similar concept to array, probably what C programming or other programming languages have. The similar kind of concept is here also. See, there can be scenarios that we have very large databases with a lot of variables involved, and for some analytic purpose or some particular modeling purpose, we can or we probably need to analyze them in terms of we need to probably transform each one of them probably into their log or squares or square roots. But if you want to do it the normal SAS way, it's a huge job. We need to write probably 1000 lines of codes and stuff like that. But we can use arrays to very quickly and very simply convert those transformations, make those transformations in place. Okay. Just to begin with, array is like to speak in a very simple language, array is probably like a train which is multiple compartments. Okay, and each compartment is capable of storing a single variable. So for example, suppose I have an array which is like say there are certain variables which are stored in a particular array. So suppose I have an array which I call as V, and I store certain variables in this array. Now suppose there is another array called L, and each of these elements of this array are L1 to L5. Now instead of telling a relationship between V1 and L1, we actually define a relationship at the array level. So the advantage is that every element of one array can automatically absorb the transformed version of the every element of the corresponding array. So that's how the operation actually goes. Okay, so in order to do that, basically, so let's start off with a very simple example. So in the data SAS help, in the SAS help library, there is a data called class. Okay, now in that class there are three numeric variables: age, height, and weight. Suppose we want to do some standard transformations on each one of them. We want to do a log or square root on each one of them. But let's start using arrays, because we'll see that how we can use arrays to much in a much easier way, in a much lesser code, how we can transform them. Okay, so so let me work on the work library only. So data now I'm defining an array. Now array names we avoid giving SAS system functions as the name, so I cannot use the SAS system functions as the array names. Okay, so we use say array called V, which has 3 elements. Why 3 elements? Because we have 3 variables to transform, hence we are using an array with 3 elements, and the members of that array being these. So the members of the array are age, height, and weight. So this means that an array called V is defined. The first member of that array is the age variable, the second is the height variable, third is the weight variable. Now suppose I define another array which is a blank array called L, with the intention that every element of L array will store the log of every element of the V array. So that is the objective of creating the L array. Now instead of linking the operations at the variable level, I would like to relate the operation at the array level. How is it being done? We begin a loop. Now this iteration will go to 3 because I have 3 variables. Okay, and now I link these. How are these to be linked? So Li, which is the ith element of L array, should be the log of the ith element of the V array. So when I is 1, L1 is log of V1. But what is V1? Age. So L1 will store log of age, L2 will similarly store log of height, L3 will store log of weight. And once I start off with a loop, I need to close it by end. So I begin the loop, do the iteration, and once the iteration gets over, I get my desired variables in my data set. So if we run this, see, I get these columns L1, L2, L3 generated automatically, storing the log of age, height, and weight, because I have defined them at an array level. Also this variable I, which is the counter variable, gets stored as a new column in my data. Now if you look at the iteration I 1, 2, 3, when I became 4, it exited the loop. Now that terminal value 4 by default gets stored in my data, which there is no reason I should have it in my data. So if I want to take it out of my data, I can just come out of the loop and drop the variable. So once we do this, my data will no longer have that I variable, but the transform variables will all be there. Right, everybody? Okay. Now similarly, by similar operation, we can probably use another array for square, another array for square root, another array for inverse, so on and so forth. So let's see how it works. So similarly, if I want to do an array for the squares of the variables, what should I do? Another array for square. So sq, suppose the array which is going to store the squares of the variables. Similarly, an array called sqt will store the square roots, and say array called inverse will inv will store the inverses of these variables. Now I need to link again each one of them through this operation. So what is sq? Sq is supposed to be the square, so sqi should be the square of vi, right? So sqi is going to store the square of the ith element of the v array. Similarly, the sqti will be the square root of the ith element of the v array, and my inverse I will be the 1 by vy. So this way I will be able to populate each one of them very easily, and so if I run this, I get all these as extra columns in my data. So sq1, sq2, sq3 storing the respective squares, sqt1, 2, 3 storing the respective square roots, and inverses storing the respective inverses, right? So this is the way by which array can very efficiently and very quickly transform my variables all at one go. Now there are a couple of problems with this. The one problem is the identification. See, here I have only three variables. So for that, L1, L2, L3, okay, I know L2 is log of height, I can easily relate, or SQ1 is the square of age and stuff like that. But however, when we have very large databases, for them, say suppose I have database with 1000 variables, then L484 is log of what, SQ385 is square of what, the relation might be a bit difficult to relate with the variable. So I need to provide the naming conventions at the level of the array definition itself. So if I don't do that, if I don't provide some naming convention at this stage, my job will be difficult for identification. Okay, so let me first do that and let me solve this problem, then we'll discuss the next problem. So by providing the naming convention at this stage, what I mean by this is that first element of L array will be known as log underscore age, which by this calculation will store the log of the first element of the V array, which is age. So with this kind of naming convention, now when I create the variables, the names actually appear as and when we create the variables, which makes our life a bit simpler in terms of the identification of the variables, right? However, this brings to me another very big problem, is that for a large database, how do I write all these names in place? So that becomes a problem. Okay, see, concept of array is this much only, that we basically define the arrays, we put variables out there, we define blank arrays, put some blank variables there and link them through a array level operation. Now what I am going to display after this is just a way by which we can very easily use Excel to get these names in place. Okay, so that will be easier for us if we don't want to type all those things, we can very easily get the names through Excel. Okay, now any proc we run, be it proc contents or proc means, as the SAS may have, we prefer proc means because it gives me the list of all numeric variables. Okay, so if I do something like this and look at the mean of the variable, and if I run this in the output window, we can get to see the list of the variables. Okay, now if I take this into in an Excel output, this output can be transferred to an Excel file. If we do that, then this list of variables can easily appear in our Excel file. So let's see how we can do this. So, and also let's focus on a data which has sufficiently large number of variables. So in SAS help, we have certain datas which can have large number of variables. So suppose there is a data called say MON 1001, which has quite a large number of variables. Okay, and suppose I decide to transform each one of them. Okay, but now I'll be using array, so our life will be much simpler. I need not write code for each and every variable. I can just do it at the array level. Now T, if you look at this column, it's more like a observation number. So probably barring this, I'll be transforming all other variables. Okay. Now for that, suppose I take this output into Excel. C drive. So now in this Excel file, I have the list of all the variables with me. Now this one I will not transform, so I delete this. Don't need the column. So how many variables do I need to transform? I need to transform 406 variables. Okay, so now if I want to do this, that basic code will remain as it is, and suppose I want to transform this. So this is my MON 1001. Now each of these loops will be, or arrays will be now having 406 elements, as well as my loop will also go run 406 times. So let me just replace 3 by 406. Okay. Now to get the original list of variables is very simple for me to just go here and copy paste the list from here, from this Excel. If I copy paste the list and put this into the code, it's so the entire list of variable comes as all the 406 variables. The list comes into my coding window. Now what remains for the each transformations, what I need to do is for each one of them I need to prefix them by something like a log underscore, square underscore, square root underscore, which can easily done in Excel through concatenation function, right? So if I do the concatenation function apply here, so log underscore is a constant string added to this variable name. Similarly, I can probably have something for the squares, something for the square root, something for the inverse. So now for the log of the variable, their names, I can easily copy from here. So I can very easily copy this out here. Same for the squares. Same for the square roots. And finally for the inverses. See, working with this Excel has made our life simpler. So instead of the 406, even this was 4000 also, I would have easily applied the same process and my job would have been much simpler. So originally my data had 407 variables because 406 plus 1 t was there, the observation number, and to that I am adding 406 into 4 because I am doing 4 transformations on each one of them. So I am getting 2031 variables in my data. So if I run this code now, check my log, I will be getting 2031 variables in my data. So if I go back and check the see, first I have the original variables, then gradually I move over to their logs, then their squares, their square roots, and finally the inverses. So all of them transform at one go very easily using the array. Okay, some of them are missing because the function, because the original values were missing, so we didn't get good numbers. So these were probably missing, hence we term them as missing. Now if I want to format some of the cells, we can also do that. If I want to format, say, some of the cells, say I want to format these variables to a particular format, I can do them. I can just copy from here and put them in a, say, 2 place of decimal format. Similarly, if I want to format the inverse, which requires more decimal places, I can put them here and have it at, say, 4 place of decimal format. So that way I can customize the way I want to format my variables, and accordingly I can deliver my output. So if I look at this now, so my the original variables were not formatted, but subsequently I had formatted the log of the variables, I had formatted the squares and the square roots, and finally the inverses of the variable. So this is basically the utility of array in the industry, where we can very easily transform a lot of variables using the array. Instead of writing one line code for each variable, I can just link them to an array by which I can create the array level operation, and I can, using the array itself, I can very easily transform the variables. Okay. So this was the basic introduction to array which I intended to discuss in this class, and I think some of you already done the SAS classes, so they are already conversant with that, and some of you who will be joining soon, so probably you need to also go through the other. The array is an advanced concept. Only when you go through the other concept, for example, we have used a lot of transformation and these kind of things as part of the array or the looping part, but these are actually all related concepts. Actually, when you go see these webinars are basically disjoint kind of things. Okay, but see in the course, when we do it in a continuous basis, all these concepts will come first, and then probably array will come up much later. Okay, so it will be more easier for you to relate to the concept. But for the time being, so for the sake of interest or for the understanding, is that arrays, if you have early exposure to any other programming language, the concept remains the same. It's actually group of variables. Array is mostly taken as a group of array or vector, whatever we call it. It's mostly like a group of variables, where if I use that arrays in operation, my life becomes simpler, because then I only need to define my operation in terms of the arrays instead of at a variable. Because see, if I, even for a small data like this, if I had to do transformations, so for each one of them I had to write one line of syntax. So probably I had to write 12 lines of syntax. Now think of the data which had, say, around 500 variables were there. Think of data which can have even 4000, 5000 variables also. So there also I could have, using array, I can very simply reduce my operation, because the names, typing them was a pain, but we have used Excel to very effectively copy paste the names in place. So our job has become much simpler in terms of the copying in terms of the giving the appropriate names to the elements of the array, and once that is done, rest of software's job. It is doing all the transformations for me and accordingly generating this data file for me, so that I can use any of the transform variables for any further operation we want to, whether it's part of any kind of statistical modeling or just standalone can be analyzed and want to be looked into. I can do that, right? So with this we come to the end of the webinar on the discussion on arrays.